have 81 and 144. So this is our W. Please keep in mind parentheses around the top and parentheses around the denominator. Since the denominator in this case is just one factor, you can get away without it, but not around the numerator. So we have W equals 81 and W equals 144. But now this is a new equation and this is a new equation. What is the new equation? W equals 81. What is it exactly? Exactly. And what about the other one? Yes. Remember how many solutions we expect? 4. Excellent. What method do we apply for the first one and the second one, actually? Square root. Thank you. This is typical. Remember 4 solutions. So what do I write from the first one? For the first. Excellent. So then, so -9, +9, 12, -12. I go back 15 pages left earlier, and I get this. So let's copy it here. X equals 108 over y. So then, 108 divided by -9 is -12. 108 divided by 9 is 12. 108 divided by 12 is 9. And 108 divided by -12, -9. As expected, 4 solutions. Since we are only talking about, and I forgot to mention that, we was such a long problem that we forgot what we were doing. We're talking about a rug, right? So then, please remind me, Priscilla, on Wednesday, this makes no sense for the rug. Everything is good. But when it comes to the rug, I can't say that the rug we have here, whatever, in the middle of the room is -12 feet by -9 feet. I can say it's 12 by 9 or 9 by 12. Both are okay. But the negative solution makes no sense when it comes to the length and the width of the rug. Please remind me. I forgot to. It was so long, and we went through so many different steps that we forgot that it was length and width of a rug, and we forgot to say. Okay. Last section of chapter 5 that we are going to look at deals with systems of inequalities this time. Last one. So let's go back to the syllabus for a moment. Okay. So we are trying to finish chapter 5, 5.1, 5.5, and 5.4, and 5.5. And I would like to finish these two, hopefully. This is really simple. It's going to look like very difficult, but you're going to see it's very simple. And 6.1 requires work. I don't know if we can finish both on Wednesday. We're going to try. And then for the rest of the 4 sessions, I would like us to review for test 3 and review for the final. That's the idea. Again, let's see if we can.
So we can finish that this week. Then the next couple of weeks would just be
review for test 3 and review for the final. Okay. That's what I would like to do. And we were thinking of test 3 on May the 4th. If we finish this Friday. It's a Saturday. It's okay if you cannot make it on a Saturday. Then I'll give you a whole week to go to the testing center, because I owe you a session. Remember, right? For us to in order to review thoroughly, I need that session face to face. Yeah. If it doesn't work, I'll give you another option. Okay. So let's continue with 5.5. Systems of inequalities. systems of inequalities. You remember part of this, not the nonlinear inequalities, but you should remember from a previous course. If you don't, it's fine too. We are on page 600. And allow me to pick the first one, and then you pick the next one. I would like to pick 34. We have a system of x plus y less than or equal to 4, and y greater than or equal to 2x minus 4. So one of the students in the previous class suggested substitution or elimination. There is no such thing for systems of inequalities. You cannot solve for anything here. The answer is we must graph. Don't try to simplify, don't try to, maybe only if you can divide both sides by a number. But other than that, you can't do anything. So here are the steps for solving systems of inequalities. In step 1, present or write the corresponding equation. How do I know what the corresponding equation looks like? All I have to do is just change this symbol into equation. I cannot touch anything else or change anything else. In case you're wondering if I'm changing the inequality into an equation, the answer is no. I need this step though. In step 2, I will graph x plus y equals 4. It's a line, so I need the x and y intercepts. When x is 0, how much is y? Very good. So the first solution is 0, 4. When y is 0, how much is x? Good. So 4, 0. In step 2, we're graphing. Four, 0, and 0, 4. These are the 2 points we just determined, the x and y intercepts. And now I have to look at this symbol before I draw. It has the equal symbol. Therefore, the line I'm going to graph, it's a solid line. If it does not have the equal symbol, I will graph it as a dashed line. So I only graphed x plus y equals 4. Do not confuse this or write the inequality on the equation. We only graph the equation.
So no equal is a dotted line. I mean a dashed line.
Yes.
Okay.
Yes. Correct. So I see that this line divides the entire plane into 2 regions, a region above it and a region below it. I like this point because it's the easiest to check with. So in step 3, I will pick a point, any point not a point on the line. You can pick this point to check with, you can pick this point to check with. I'm going to be lazy and pick 0, 0, checking the bottom region. So in step 3, I pick a point. 3, pick a point to check the inequality. You cannot pick a point on the graph, on the line. If the graph passes through the origin, you cannot pick the origin. In this case, it doesn't, so I will pick the origin and go back, and here's what I do. 0, 0. Is 0 less than or equal to 4? Don't answer just yet. If you say it's true, I will be shading the area where the point came from. If you say, no, 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 it's false, then I will have to shade in the opposite. So is it true or false?
It's true.
It's true. So therefore, I have to shade the region, this entire area, and points on the line represent solutions to this inequality. And no one can present the solution in any other way but by graphing it. So when we talk about systems of linear or nonlinear inequalities, substitution and elimination mean nothing. Do not attempt to solve, because you can't. You have to graph, you have to shade in. Now I'm completely done with the first inequality. In step 4, I will repeat for the subsequent inequalities all the steps from above. 4, repeat. 4, y equals 2x minus 4. When x is 0, how much is y? Negative 4. 0, negative 4. When y is 0, think for a moment, don't rush, move negative 4 to the other side, and divide by 2. Very good, thank you, Michelle. So this is 2 comma 0. You move 4, so 4 equals 2x, therefore x is 2. So we go back to the same coordinate system where we will be plotting the 2 points we just determined, 0, negative 4, and 2 comma 0. I will not draw the line before I check the inequality symbol. Is the equal symbol there?
Yeah.
Good. So then I will graph it as a solid line. On the line, I write the equation. I did not graph the inequality yet. I only graphed the equation. Now for this equation, I see that the line divides the plane into 2 regions, the one below and the one above. In the one above, I see my favorite point, which is 0, 0. I go back and I get 0 is greater than or equal to negative 4. If you say it's true, I will shade the region where the point came from. If you say it's not true, it's false, then I will shade in the opposite region. Is this statement true?
Yes.
Since it is true, I will have to shade in the area where the point came from. And this area represents solutions to y greater than or equal to 2x minus 4. It's the only way to present the solutions. But since this is a system, I'm interested where I should pick points that make both inequality true at the same time, as we did with all the previous equations, systems of equations. Here, all these verify both equations. So the same idea with the inequalities, with the systems of inequalities. I need to pick that region, that territory that complies or consists of solutions that verify both inequalities. So I don't want this gray and I don't want this purple. I want gray and purple at the same time. Do they overlap? Yes. All points on this line and the vertex, all points on this line, and everything else in between. So if I pick in the green area, I will pick a point that verifies both inequalities at the same time. If I pick in the gray, only one of them. If I pick in the purple, only the other. If I pick here, none of the above. So the solutions are only here. And now we can pick and practice with the nonlinear. These both were linear inequalities. So now we should look at nonlinear.
So like, what do you write as the answer?
Only the green area that you see, and I wrote both.
Great.
There is no other way.
So you just graph them and then find that area.
You graph completely the first inequality. When you're done and after you shade it in, then you will do the same steps. You will go through the same steps for the second one and then intersect. If there is no intersection, then you'll say no solutions. If there is an intersection, you will point to the intersection. There is no other way. Yes, Doris?
I know this. You've said this before, but
That's okay.
could you just so for the y equals 2x minus 4, we took. Do we multiply the 2 times 0?
Yes, that's why I covered it. When I multiply anything by 0, it's 0. That's why I put my finger on it.
I feel like I'm.
when x is 0. 2 times 0 is 0. It disappears. That's why I covered it with my finger.
Okay, and then
It's gone,
well, not 0 minus 4, but oh, it is 0.
right? That's how we get 0, negative 4. Now, when I covered y, because y is 0, then I have to move forward. That's why I wrote here. 4 goes to the other side. 4 equals 2x, which means x must be 2. Only 2 times 2 will be 4.
Okay, so just put it in.
No, you just divide. That's all I meant. From here you divide. 4 divided by 2 is 2. We're solving this equation. Is that better? Other questions for me? Anyone? Okay, so now let's look at something that is a little bit more difficult because it's nonlinear. Linear is pretty straightforward. Okay. On page 600. Let's look at 49. So x squared plus y squared. That's why I want to review everything more than once. And x squared plus y squared less than 16. Okay. Because it's a lot of material. It's not that difficult. And I know you understood it when we presented everything, but it went away because it's been 3 months and a half. So that's why I need to review. That's why I'm hoping that we can have that test outside of class. Okay, first step, the equation. And the question is, what is it? Can anyone tell us what equation is this? Say it again. Careful. Careful. No, there is no ratio. Chapter 2. It is sort of a polynomial, but it has 2 variables. Polynomials cannot have 2 variables. So we could say somewhat polynomial, but it's something else maybe from our past. No, not with 2 variables. Something with 2 variables that had power 2. Say it again. No. Equations with 2 variables and x was squared and y was squared. We had it on the previous test, and you also graphed it. It's definitely not a function.
Did my class do this?
Gotcha.
Wow, I didn't write that down.
But you graphed it, so you have it.
Yeah.
I have to know how to graph x squared plus y squared equals 1. Otherwise, I can't continue. I have to know what it is. Okay, I'm on strike for the next minute. I can only be on strike for 1 minute, though. We graphed it. Look at the second test. If you have it, it's right there on your test. Or you look at the solutions.
Second test.
I refuse to even give a hint. Oh, I gave a few, though. Yes, Cece?
Inverse? No.
No? It wouldn't have an inverse, though. because of x squared and y squared.
It's not. No, it's not that.
It's not because of y squared. X squared is a function, but y squared will not. Say it again? No, because it doesn't have the variable at the exponent. Let's go back to chapter 2, section 2.8. That's the last hint. Exactly.
I was thinking that.
Very good. It's a circle. What is the center, please? Yes, but for this particular one. Indeed, it is HK. But for this particular circle, what is H and what is K? Excellent.
Oh, I see.
Something one.
The radius is 1. What do we subtract from X here? What do we subtract from Y here?
The H and K's, right?
Right, so how much is H and how much is K? What do we subtract from
We
X?
don't know.
Wait, no.
Well, yes, we do. Of course we do. The center is the origin with a radius of 1. We don't subtract anything. Perfect. So let's graph it. I have to stop and look at the inequality symbol. Is there an equal symbol? Yes or no? No. So I cannot draw it as a solid curve, meaning points on this curve will not be part of the solution. Just this, the circle, is x squared plus y squared equals 1. This circle divides the plane into 2 regions, the inside and the outside. Can anyone tell us which point would you pick? Would you pick a point on the inside, like my favorite? Or will you pick a point here, 10, 10? It doesn't matter which one you want to work with. I prefer the origin because it's the easiest one to work with. But you can say, no, forget about the origin. I want to choose 10, 10. It doesn't matter to me. So you want 0, 0, the origin?
Yes.
So we are checking the inside. So 0 greater than 1, 0, 0 greater than 1, true or false? If you say true, I'll shade in the inside of the circle. If you say false, I'll shade in all the outside of the circle, but not the inside. Indeed, it's false. So I have to shade in everything on the outside of the circle. All this region is x squared plus y squared greater than 1. Well done. Now I repeat for the second one. Can anyone tell us what type of equation is x squared plus y squared equals 16? Haha! X squared plus y squared equals 16. What is the center? 0, 0, and the radius is, careful, the radius is
Square.
4. Perfect. So let's go back. 1, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4. The inequality has the equal symbol? No. So then I cannot graph it as a solid curve. The green circle is the equation is x squared plus y squared equals 16. It divides the plane into 2 regions, the inner and the outer. Would you like to choose the 0, 0 again or another point? Okay, so now 0, 0, 0 less than 16. Don't say anything just yet. If you say true, I will shade in the inside. If you say no, it's false, I will shade in the outside.
True.
The green territory, the inside of this circle, represents x squared plus y squared less than 16. I don't care for green, I don't care for purple, but I do care for both. That's where the solution will be, or solutions will be. I have to pick ordered pairs that verify both inequalities at the same time. One of them is purple, and the other one is green. Do they overlap?
Yes.
Yes. Not on the circle, very, very close. Not on the circle, but very, very close, but everything else in between. Like a donut. This is the orange is the both. If you pick inside a small circle, only the second inequality will be true. If you pick outside of the big circle, only the first inequality will be true. You must pick inside the donut, not on their circumferences, in order to solve the system, both inequalities at the same time. We have time for one more if you'd like. If not, we can start 6.1. I think we should not break it. I think we should choose another. Okay, let's choose another. On page 54. Same page, 600. And this is the end of chapter 5. We have x squared plus y squared less than 4, which is pretty straightforward. And we have y minus x squared greater than or equal to 0. Okay, the first one will take very short time, right? Because we have already x squared plus y squared equals 4. And we know that this is a circle centered where?
At the
Origin, with a radius of?
2.
2. Very good. That's not a big deal. We had it 3 times already. So 2, 2, 2, 2. But I have to stop. I cannot graph it before I check. Do I graph it as a solid curve or not? Very good. So this piece, just the circle, is x squared plus y squared equals 4. That's the equation. We did not graph the inequality yet. So now the question is, when I plug in 0, 0, because I'm checking the inner, I get 0 less than 4. If you say it's true, I will shade in the inner. If you say it's false, I will have to shade in the outside. It's true. 0, 0 is less than 4. So it's true. So the inside, the green territory, it represents solutions to x squared plus y squared less than 4. Okay, now we have the other one. Y minus x squared equals 0. But that is y equals x squared. And we have so much experience with this function, with transformations, with polynomial. How do I graph y equals x squared? Exactly. Centered where? Or where is the vertex? At the origin, of course. We graphed that so many times. Solid or not? 1, 1. When x is 1, y is negative 1, 1. So 0, 0. So this is the graph. This is y equals x squared. It passes through the origin. I can no longer use the origin for this one. I'm going to pick this point because I want to check the inner part of the parabola. let's say 0 comma whatever you want. Not 1 and not 2. Has to be above. 0 comma 7 it is. Perfect. Y equals 0. 7 squared is 49 with minus in front. So is negative 49 greater than or equal to 0? If you say yes, I will shade in the inside. If you say no, I will have to shade in the outside.
No.
No, very good, awesome. So this is y minus x squared greater than or equal to 0. I don't care for either one. I only care for both. Because I'm solving a system and both inequalities have to be correct. Have to be solved, I shouldn't say correct. They have to be solved. So, where do I look? Where they overlap. So everything here and everything very, very close to the circle and everything inside. This is the both. Any questions?